Hello there, and welcome to another episode. My name is Simon, and these are the Python series. This is which episode is this? It has been a minute since we had one. We are supposed to be having such episodes on Monday, Wednesday, and Friday, but we didn't have one on Monday. But regardless, we are here. I think this is episode 13. Oh, wait a minute. Brayo, morning. Yes, I'm recording. Yes. Yes, so this is episode 13 of the Python series. And in this episode, we are going to be looking at classes and objects in Python. So depending on what we have been looking at, most of the concepts we have looked at are what we categorize in basics of Python. Python has three different levels. There are basics of Python. That's what we have covered so far. And these classes and objects are in they fall under intermediate Python. So to do AI, you need all the basics of Python and some few concepts in intermediate Python. But still, it doesn't mean you don't have to progress to advanced. You can still progress to advanced to become a professional or better. So we are going to be looking at classes and objects, as I said. Okay, so what do we mean when we talk about classes and objects? You see, there are programming languages which are called object-oriented languages. So in such kind of languages, you have a chance to build your systems when you're arranging the programs in form of classes and objects. So this gives you a chance to have a clear organization of your code, and it makes the whole process of software development efficient. So when we talk of a class can be given a definition as a blueprint for creating objects, and it defines a set of attributes and methods that the created objects will have. And then an object is an instance of a class, and it represents specific examples of the class and has the attributes and behaviors defined by the class. So a class, like we have said, it is a blueprint. You use it to define how you want different objects to look like. For example, I would take an example of you're building a mobile app game having some characters like most of you like playing Temporan. So you have their characters which are maybe you have a dog, you have a lion somewhere, you have a cat. So when you look at some of those characters, they have related features. First of all, they are all animals. And then all the objects or animals I've mentioned, all of them have four legs. And then they have two eyes. And then they have several other related features that you wouldn't want you to repeat yourself when you're creating each and every one of them. So what do? You just create a class called animal. So that is the blueprint which you will use to create all the objects which have those features or characteristics. So you create one class called animal, and then you give it attributes like four legs, two eyes, blah, blah, and several other methods, which you are sure of that every animal that is in that mobile game that you are creating has. Then, or where do objects come in? Now, if you want to create a dog will now inherit all the features that the class animal has to have all the attributes you defined in the class animal. It will have 4 legs. It will have 2 eyes. It will do all the methods. It will implement all the methods you put in that class because it is an animal. Then you won't stop there. You will give also specific features that distinguish that dog from all the other animals created from the class animal. I hope you're getting the clear picture. So a class helps you to give a blueprint of the objects that will be created. And then an object is just an instance of a certain class. It has all the characteristics of that class and then the specific characteristics that distinguish it from other objects from that class. So we shall see from examples and we are going to understand this concept better. So why do we use classes and objects? First of all, to enable encapsulation. So this enables us to bundle data and methods and that operate on the data into a single unit. So instead of having programs, a program with very many functions distributed there, not arranged, not organized. So if you're building your programs using classes and objects, you will know that if I'm building a class animal, all the methods related to the animal will be organized inside that class. And any other method that is not related to the animal won't be inside that class. So that's what we are trying to mean here. Then reusability, write the class once and create multiple objects from it. You will create one class animal, and then you create several animals from it. You create a dog, you create a cat, you create a lion, instead of having to create all these animals independently. Then modularity, you break down complex programs into smaller manageable units. So when you organize your software development process into classes and objects, it helps you break down a complex system into more manageable units. Then inheritance and polymorphism. So you are able to reuse and extend existing classes without rewriting them. So these are some of the concepts you should know about classes and objects. So moving on, how do you create a class in Python? You use this keyword class and then followed by the class name. The class name has to be capitalized. You're seeing this C is capital. So you capitalize the class name, then you put a colon. So a class is another object in Python whereby we use these indentation rules. Like you have seen def keyword here. It's beginning from an indented point. It's not beginning from the other side. So a class, just like the functions, loops, and conditional statements, they do some indenting when you're defining them. So after that, let's define some of these things here. We're saying the init method. It is a special method that initializes new objects. It can also be called a constructor. We are going to talk about it in the next few minutes in details, but for now, just know that when you're defining a class, you define this init method, and this enables you to describe all the attributes that the class you're creating should have by default. So every class you create will have these attributes here: make, model, year, like that. Then self refers to the instance of the class, allowing access to the attributes and methods of the class. So when you use self keyword here, you're trying to make the compiler know that when you're trying to create a certain instance of this object, when it meets an attribute make, it should assign it to the parameter make, which is here. So this is, we shall also look at self in details, but all you should know is that it helps to create an instance, to define an instance of a class and make the compiler know that the attribute make or that attribute associated with the word self is referring to the attribute defined in the constructor here. Okay, so that is how you create a class in Python. So should we create one? We were talking about animals a while ago, so it would be good if we try to create something like that. So let's create a class animal. You said you have to begin to capitalize the first letter. Let me first zoom in a little bit. Is it zooming? Okay. It's too much. Maybe that is fine. So let's create a class animal. So, hey, what did I do? Okay. So you have to write the word class, then the name of your class with capital letter at the beginning, then you put a colon. Then when you press enter, it will indent itself automatically. Like, hey, what did I put here? It's supposed to be class. Okay. So when you come here at the end and you press enter, the code will be indented automatically. This means that the block of code that should fall under the class animal should always begin from where you're seeing the cursor. So inside here, I have to define the init method. This init method here. Where are we? This init method here. So I'll come and say def, because it is a method, that's why I'm using the def keyword init. Then init must by default have some um, parameters here, with self being the first. So self must always be there. Whenever you're creating methods inside the class, the self keyword have to be there so that you're able to define your instances or the objects of this class well. So self is always the first parameter. That's what you should know when you're creating methods inside the class. Then, which attributes will this animal have? Maybe number of legs, and then maybe class of the animal. What else? Maybe we can have color. Okay, this is a keyword. That's why I'm getting that error there. Maybe we can say animal class, and then we can have the color. We can have that for now. Then inside here, like you're seeing in my slides here, after defining the parameters here, you have to come here and say self dot, you put the parameter here, then you equate it to this. So this means that if you're in an object, this one here will be referring to the attribute in your object. And then you'll be telling the compiler that that object, that attribute is referring to the parameter given in our constructor. So coming back here, let me try to do that. I would say self dot number of legs equals to number of legs. Next, self dot animal class equals to animal class, and then self dot color equals to color. So just like that, I've finished to define the attributes that the class animal should have. So every object or animal that I'll create from this class must have those attributes. So I can come here outside the that class and try to create some objects. For example, let me create object dog. I can say dog equals to, then you say animal. Okay, so that is how you instantiate an object. What we are doing is we are instantiating an object, or we are creating an instance of that class. And this specific instance is the dog or object dog, because we said an object is an instance of a class. So we've created one instance already, which is dog. So inside here, we have to give it the parameters. These parameters you're seeing here. Did we put all of them? 1, 2, 3. Are they all here? Animal class. We didn't put number of legs here. Okay, they are there. It is fine. So inside here, let's define those parameters. So the first one refers to the number of legs. Number of legs, the dog has 4. Then, comma. So you're even seeing the guide here, trying to guide you that you have finished putting number of legs. Now it requires you to put the parameter for animal class. So which class of animals is a dog? Okay, let's assume we are categorizing animals as domestic and wild. So this one we can put domestic. Then you're seeing the guide now has moved to color, indicating that we should put the color for the dog object. So we can put maybe brown. And now that is it. We finished creating an object from our class. So we can come here and try to access these objects attributes. Now we can say print dog dot color. Dog dot color. When we save this and run dog dot color, are we running? Okay. Dog dot color. What's the color of this dog that we have created? Is it coming? It should come. Taking almost forever. So we are still progressing. We've created an object. Okay. You use the class name and you provide the required parameter. That's what we have been doing. Then when you're trying to access the attributes, you use the dot operator. This dot here is not a full stop from your English. This dot is called the dot operator. It helps you to access attributes from a class. So you're seeing brown has been printed here. We'll use the dot operator here. You put the class name followed by a dot. Dot means that you're trying to access an attribute from the this object here. So the color has been printed there. If you want the number of legs to be printed, you put number of legs, and the legs shall be printed, and that's that. So that's how you create an object and you try to put some attributes. And so we can create another instance here of that class. Maybe now we want to create a cat, or we can create a hen. We are creating this object hen, but we want it to inherit the attributes from the animal class. So we put animal. Then inside there, we define those parameters like you're seeing the guide here. Tells you put the number of legs for a hen. So the hen has 2. Which class is it? Domestic. Okay, this should be a string. Domestic. What's wrong with my spellings today? Domestic. And then color, maybe white. Today my grammar is very bad. Okay. So we have created another object or another instance from our class. And to try to access some of its elements, we can say print hen dot animal type, animal class, and it will print for us it is domestic. Or we can even use some descriptive text. We can say this animal is, okay, then we put here animal type. So this requires us to use the self keyword here. Self dot animal self dot animal type. Oh, okay. We don't use the self here, we use hen because we want to print details about the hen. So we say hen dot animal type, and then this animal is, and it is, okay, hen dot color, in color. Someone can try to guess what we shall get as the output when I save and run. Oh, okay, we have an error. Animal object has no attribute, animal type. Yeah, that is true. So what crime have we committed? We are referring to attribute animal type, but we don't have it here. It is called animal class. So we come and correct that. Animal class. There we go. Save and run. So this animal is domestic and it is white in color. So that is that. If you want to do this about a dog, it is the same thing. Okay, so let's try to include some methods here. We've just put attributes. Okay, the init is the method also, but we want to include other methods also. So maybe you want to put a method that returns the number of legs and the class where a certain animal belongs to. So you can say return, okay, let's return class of animal for now. Return class of animal. So what parameters will this one take? It has to first of all take self. We agreed every method should have that self. What else should it take? What else should it take? Okay, colon, and then we say return self dot animal class. That's what we want it to return. Then, so that method is there. When we call it, to return for us the class of a specific animal or from which has called it. So we can print, if we want to determine the class for hen, we shall say print, and then we say hen dot. So we want to access the method, still we use the dot operator. We are saying in the object hen, you access the method return class of animal. Since it is a method, we have to end it with that. Then when we save and run, there we go, it is returning domestic. So that is what a method does. We say a method or function. Method is the same as function. Don't get lost. When we call a function, it does for us what we want it to do. And that's what this one has done here. So that is that, guys. So moving on, that's how we can create a class and objects from a class and try to access some of the attributes and methods from that specific class. Methods, we have also looked at them. Okay, they are functions defined inside a class that describe the behaviors of the objects. So these attributes here, they define the behavior of the objects that we are creating. For example, number of legs, the class of the animal, the color, those are different behaviors, and every animal has different behaviors. But then their characteristics are not very different. That's why they are in the same class. Okay, I think we have literally looked at this. Calling a method, we have also looked at that. We use the object name followed by the dot operator and then followed by the method name. So let's talk about the self keyword in details. So the self represents the instance of the class. It is used to access variables and methods associated with the object that is being created or used. Self is not a keyword in Python, it's just a conversion. It's widely understood to mean the instance of the object. Okay, so like we said, when you're creating any method here, this init is the default method or function that must be in every class. Even if you don't have it, it might run, but it's always better when you have it. You see, we're having the self there. Even in this method, we're having the self there. So this self should always be in every method. Why? Because it enables us, if we create objects, we are able to access the attributes of that specific object. This self, if you've done Java, it is similar to the this keyword. In Java, we use the this keyword. So here we are using self. In Java, it is this, but they do literally the same thing. They help to access attributes or methods of a specific objects created from a certain class. Yeah, it is similar in functionality with this keyword in Java. Okay. The self ensures that each object maintains its own values for attributes like make, model, and etc. So the way you're seeing here, when we came here and said self dot number of legs equals to number of legs, this means that in an object created from this class, the number of legs assigned here when, for example, let's take an example of a dog. This, when you say self dot number of legs, it means the number of legs put here as arguments when we are creating an object dog. It refers to the parameter number of legs, which are here when we are creating the class. So that's what that means. And it is self keyword that is helping us to create that relationship there. Then, yeah, that is the whole thing there. So you should always include the self as the first parameter of instance methods. It allows each object to store its own data, making class more powerful and flexible. So you can see here that a dog has its own behaviors here. Number of legs, 4, color, brown. The hen has different ones. Color, white, number of legs too, although both are domestic, but it is that self keyword that is enabling that functionality. If you eliminate it, you get several errors there. Then what about the init method? Why do we have it? So it is a special method in Python classes that is automatically called when an object of the class is created. So whenever you create an object, like here you're seeing this dog object, that init method is automatically called. That's why you've seen that here to access this method return class of animal from this class here, we had to first call it from here. If you don't call it, it doesn't come. But that in the init method here, we didn't call it when creating any of these objects, hen or dog, but it has come automatically. That's why we are able to put these parameters here, because that method has been called automatically, and then we're able to put those parameters, define the behaviors for each object. Then it initializes the object's attributes with initial values allowing each object to have its own unique data. Okay. Init stands for initialize, not construct like in some other programming languages, but it functions similarly to a constructor. So init is the default constructor. A constructor means a function that is used to create objects of a certain class. So the init stands for initialized, is the default constructor that every method of a specific class calls when it has been created. Moving on, I will reach the take home. So before the take home, let's do something else here, something a little bit more descriptive, something a little bit practical. So let's try to create a class. Let's refer to, should we refer to the Premier League? I normally see most of you playing certain computer games like FIFA. There is one called Dream League you play on your phone. So want to try and see how they try to create some of those objects you interact with there. But we shall not go into details. But we shall have a glimpse of what happens in the background or behind there when they are creating those objects that you like interacting with there. So let's assume we want to create a class called Premier League. Premier League. Premier League, let's just call it Premier, but it will store information about different clubs. That if you're playing, you can be able to choose a certain club, play with it, and stuff like that. So the class is Premier. So from Premier, oh, what did I do? This is class. What did I put? Okay. Then, okay. So we have created our class Premier, and it will store information about different clubs in Premier League. Then we put our default constructor called init. Init, it is there. Okay. Okay. The self is there by default. And then we want it to store team name. Want it to store team name. Want it to store manager's name. Manager's name. You can also store the stadium. You can also store the stadium. You can also store the points a certain club is having, and can also store the results for a certain match day. So then we come here, we begin self dot team name equals to team name. Let me copy this. Then self dot manager equals to manager. Then self dot stadium equals to stadium. Then self dot points equals to points. Then self dot results equals to results. So that is that. Then which methods can we include here? Maybe let's put a method which can be able to update the team's points depending on its result on a specific match day. So we can create a function called, what can we call it? Update, update points. Update points has to have self by default. Then what does it take in? What does it take in? It takes in the points and also takes in the results. You just give that method the points and the results, and it updates the points for that club on the table. Okay. Okay. So inside here, we want to write that functionality. Okay. So results, the result can either be a win, a draw, or a loss. So what do? We can say if results equals to win, if result equals to win, what do? We can return, okay, no, for returning, we can update points. If someone gets a win, those of you who watch football, you know that the points are added. They get 3 points. So on the points that a team is having, you should add 3. That's what this means. It means from points that the team has, add 3. Then a leaf result equals to draw. A leaf results equals to draw. Points, points equals to points. What do we give someone who has gotten a draw? We just give them 1 point. So we add 1 onto the points. Then else, can just put else here because there is no other option. Maybe we can, okay, let's do this. A leaf result equals to loss. A leaf result equals to loss. Points remain unchanged. So we can just have points equal to points. Then else, if someone gives in a certain result that is not defined here, we can tell them invalid results. So the result should either be a lose, draw, or win. Anything else is invalid. So we have defined our method there. So this method should be able to return something. And since we are calling it update points, so it should return the updated points. So we can return points, which will be updated. So whenever you call that method, it just gives you the updated results. So we have finished creating our object. So sorry, our class Premier League or Premier. We've defined some attributes and we put there some method, one method there that we want to have for now. So let's create a team, an object team from the class Premier. We can create menu. Okay. Okay, we want to create Man United. Let's try to put some of those parameters. Team name. So let's include team name here. Man. Okay, we can call this team 1. Team 1. Okay, then team 1 is Man U. Then, okay, now I know. Do you know why we are not having the okay, so we have not instantiated this object yet. That's why we are having that. So team 1 equals to Premier, like that. Then we now put those parameters. The team name, Man United. Hey, what happened? Man United. And then you see this one tells us that we should put the manager. So the manager is, what's wrong? Undo. Okay, it messed up somewhere. Let's get rid of this. Okay, we are back. So we put the manager, Ten Hag. Hope that's the spelling. Then we put the stadium. What's the stadium? Old Trafford. Then after that, the points. What Man U's points? Is it 8, 7? One of those. Then after that, result. What's the result? The previous result, was it a draw? Okay. So we've already created an object from the class Premier Teams. And now, if we try to access, we want to know team1 dot team name. We want to know the team name for team1, and we print this. Okay, it is returning Man United. So that is the team name. If you want to know the manager, we just put here team name team1 dot manager, and we shall return Eric Ten Hag. So that is that. Let's create another object. We shall just copy this. Okay. We shall just copy this and modify. So we are creating another team, which is team2. Team2 from the same class. Let's create Man City. Who's the manager? Guardiola. Okay. What's the stadium? Etihad. Okay, how many points does it have? Is it 17? What was the last result? It was a win. And just like that, we have another object. So if we say print team2 dot points or manager, and have manager, it will print for us the team manager for team2, and there we go. So that is that. So now we want to let's try to access the points for Man City. Let's try to access the points for Man City. We say print. We want to implement our method which we created. We shall say print team2 dot points. You're seeing we're having 17, but these are not updated, because if it has a win from what we have created here, it shows that it has a win. Let's update those points if that team has gotten a win. So we can create a variable here, updated points. And these updated points, we now call our method update points. We're calling that method to update the points for us. But in order to do that, okay, this is wrong. We should put the object first. We want it to update the points for Man City or team2. So we say team2 dot update points. Then we give it the parameter. You see, it is asking for the points. So points We put how many points does it have? We can even just put team 2. You can put there 17 manually or put team 2 dot points. And then it wants us to put the result. Then result, it is team 2 dot result dot results. So on the next line, we now want to print the updated points. Print updated points. When we save this and run, there we go. We now have 20. So it has worked successfully. Let me show you how it has worked. Calling this method, it has checked, is the result equals to a win? Yes. And since our result was a win, it got the points which were initially 17 and added 3. That's how we are getting 20. So that's how we are getting 20. I'll upload this code on GitHub, on our GitHub account, but you should also practice on your own. But I'll try to upload it on our GitHub account, that is at Indabaxcab or just Indabaxcab. When you go to GitHub, you search Indabaxcab, you find our repository there. So let's also update points for Man United. Let's assume Man United has also played a game and they've gotten a win. So we can call it updated points Man U. Never mind this, my naming. It's a little bit not good for today, but we can go with it for now. So we call team1 dot update points. Then we give the current points. For this time, let's just put there the points that it has. It currently has 7, and the result is win. So you can either do this or do what we did for the case of Man City to give the same result. Then on the next line, we print updated points Man U, and it will print Man United's updated points. There we go, 10 from 7. So that is it with creating methods and trying to work around with them, trying to implement them. So this is a bit of the logic that is implemented in those video games that you normally play, FIFA, Dream League, and so on. They use the concept of classes and objects to create those teams that you interact with there, you play, enjoy. So in order to create those different players you see, like you see a player created who looks like Ronaldo, looks like Messi, looks like Saka. So they create one class player, and they know that every player should have this. Every player should have each other, should have this, should have this. They look for those related attributes that each player has. So you just start creating objects from that class. That's how they are able to create very many players. You just imagine all the players that are in the world, and all those players are in the game FIFA. You just imagine if they had to create every player independently. It will take you a lot of time, but they just created one class player, and you just create instances. The same thing, or you just create objects. The same thing with teams. You just create one team for Premier League. You just create one class teams, and then you create objects from teams where each team should have a stadium, should have a manager, should have things like that. Then you create the 20 other teams from that class, uh, and many other concepts there. So just know the concept of classes and objects, methods, functions. They are used a lot in most of those softwares which you enjoy and you like using currently. So I think we are done unless there's a question which you can drop in our WhatsApp group or in the comment section. I will be able to help you. If you're facing challenges, always reach out to us, me, or any other person from the Indabax Cub team. You will be helped. So this is your take home. You create a class named student. Yeah, because you can see there are a lot of students at CAB, but we just want to create a class student. And then we create different objects for every student. Then it should have three attributes: name, age, and the subjects. Then you implement the following methods: add subject, which adds a given subject to the subjects list. Maybe a student already has some two subjects. Then you create a method that adds another subject to the student. Then remove subject for deleting a certain subject. Then display subject. This method should just display the subjects that a given student has. Okay, yeah. Then finally, you create an instance and implement the methods. Create an instance of the student class with a student's name and age. For example, student one, you should create student one with such attributes. This is the name, age, and subjects. You should also include them somewhere. Then add subjects like math, science to student one using add subject. Remove a subject like math using the remove subject. These are methods. You'll be using these methods defined in the class to do these operations. Then display the updated list of subjects using display subjects. All these are methods defined inside the class. I hope this will be simple for you. If you face any challenges, don't hesitate to post your question in the comment section or in our WhatsApp group. With that, let me call it a day. We meet again on Friday with another episode. So today in the afternoon, let's meet in our usual meeting place, the computer lab, as we begin our CAB AI series. There's a very good session awaiting you there. So let's meet there. Okay, my name is Simon, and these are the CAB Python series. Till next time, I'm out.